Hello, Ms. Toshner. Today we are going to be doing problem number 52 from 5.2, the unit circle. And this is going to be my week one video assignment. So let's just get started with defining a couple of trigonometric functions. So the first one we're going to need to define is sine of theta. So sine of theta is the ratio, is one of the six trigonometric ratios that describes the relationship between the opposite side of a triangle over the hypotenuse side of the triangle. Okay, and it can be displayed. I can draw a triangle right here. If we go theta right here, and go A, B, C, or A, B, C, then our sine value would be the opposite over the hypotenuse. So A over C. And so on the other hand, we have cosine of theta, which is going to describe the relationship between the adjacent over the hypotenuse side of a triangle. And so in this triangle, we will have sine of theta, or cosine of theta, sorry. Theta equaling B, which is the adjacent side, over C, which is the hypotenuse. So B over C, okay? And so in the problem, we're given that, here, hold on. In the problem, we're given that sine of t, which is an angle, is equal to 3 over 8. And so that means that our opposite side equals 3, and our hypotenuse equals 8. Okay? And so what it's asking for is cosine of t. So that's basically what we're trying to solve for in this problem. Okay, so let's get started by drawing a coordinate plane. Okay, so if we label these axes, and these are the quadrants of the unit circle. So it starts with 0 pi, pi over 2, which is 90 degrees, pi, which is 180 degrees, and 3 pi over 2, which is 270 degrees. Okay, so we're given that this this function t is in the second quadrant. So let's draw a triangle here, and this is our angle t. Okay, so what we're gonna do is we're gonna use our sine value that's already given over here, and we're gonna draw it over here. So the opposite side is gonna be 3, and the hypotenuse is gonna be 8. And so in order to find cosine of t, we're gonna have to find the value of this side. So this side length is going to be found by using the Pythagorean theorem. And so the Pythagorean theorem can be used to find the third side of any triangle when given 2. So the formula is a squared plus b squared equals c squared. And one important thing to note is that the a squared and the b squared, the a and the b values, have to be the opposite and the adjacent side. And the hypotenuse has to be the c value. So the a and the b side, the hypotenuse and the adjacent side are interchangeable because of addition. You can have them either way. But the c value, which is the hypotenuse, has to be on the right side of the equation or after the equal sign. So we're just going to plug in some numbers here. So we're going to say that our a value is going to be 3, so 3 squared plus b squared equals 8 squared, which is our hypotenuse. So we're going to go 9 plus b squared equals 64. So I'm going to subtract 9 from both sides. B squared equals 55. And so to simplify further, we're going to take the square root of both sides, and then we're going to end up with b equals plus or minus root 55. And so an important thing to know about these kinds of problems is that these values could go positive, these values could go negative. So it's very important to understand the basic rules of the unit circle. So I'm just going to draw a very unorganized graph here just to show you one thing. So in this quadrant, all trig is positive. In this quadrant, only sine of theta is positive. Here, let me just have greater than 0. In this quadrant, tangent of theta is greater than 0. And in this quadrant, cosine of theta is greater than 0. And so if we can fill in the reciprocal trig functions, but it's not really necessary here given this problem. But what we do need to realize is that only cosine of theta is positive in this quadrant and this quadrant. And we are operating in this quadrant. And since we already know that our hypotenuse is positive, given this expression here, and the given value, then we know that the numerator of our equation, which is gonna be root 55, has to be negative because cosine is negative in quadrant 2. And if the hypotenuse or the denominator is not negative, then the numerator must be negative to make it a negative value. So b is gonna end up equaling negative root 55. So I'm just gonna erase this right here. And so one thing I just want to stress more is something that's unique about the unit circle is this image right here. Okay, you have to know that sine of theta is positive in quadrant 2, tangent of theta is positive in quadrant 3, and cosine of theta is positive in quadrant 4, and all the identities are trig functions are positive in quadrant 1. Okay, so just to reiterate, I'm going to draw this out. So we're looking for cosine of theta. And so if we know that the denominator is going to be positive, which is our hypotenuse, then our adjacent side, okay, okay, so let me just rewrite this real quick. So it's going to be negative cosine because our value is going to be negative because cosine is negative in quadrant 2. So a negative value for cosine is going to happen when, uh, and if there's also a positive value in the hypotenuse or denominator, then this adjacent side or this numerator has to be negative to make this value negative. And so I'm not drawing a negative like in front of here like that, but I just want you to understand that uh, the negative value of cosine happens when the adjacent side is going to be negative, and we just solved for the adjacent side. So given that, we're going to use our knowledge of cosine of theta to finish off solving because we have all the sides. So the adjacent side is negative root 55. So negative root 55 over the hypotenuse. The hypotenuse is positive 8. So this is going to be our final answer. Cosine of t equals negative root 55 over 8. And that's basically it. Just want to show this picture one more time. And yep, that's it.